Let's go to page 531, and this is lesson 11-6. The objective of this lesson is to find sums of an infinite geometric series having ratios with absolute value less than 1. So let's look at this series. You got 1/2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus dot 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 dot. Okay? So notice this, there is no last term, means this is going on forever. So this is an infinite series. It doesn't end. Now, before we get into how to do this, let's go and just go over some, let's go and look for some of the partial sum. Okay? So partial sum means you're only adding certain number of terms. So S1 means you're only adding the one term. Okay, so again, S1 means sum of one term. Well, if that's the case, then you would just have one term, so it would be just 1/2. S2 means you're adding the two terms, means 1/2 plus the next one plus 1 over 4. And again, you can go and work this thing out yourself, so it will become equal to 3 over 4. S3 means you're adding three terms, so it would be 1/2 plus 1/4 plus 1 over 8. So again, S3 means sum of three terms, so this will equal to 7 over 8. Okay. S4 means you're adding the four terms, so it would be 1/2 plus 1 over 4 plus 1 over 8 plus 1 over 16 equal to 15 over 16. And if you keep going, okay, when you get to S10, again, you write out the 10 terms and you add it all together. Okay, so this will equal to 1/2 plus 1 over 4 plus 1 over 8 plus 1 over 16 plus dot 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 plus 1 over 1024. So this will be a S10. This will be a T10, and this will equal to 1023, 1024. Okay, so these are called a partial sum because you only do part of it. Okay, so if you notice the formula, so if you start with your sum formula, so S of n, and this is your, so that's, suppose you start with this equation, geometric sum, okay? So you go to T1 times 1 minus r to the n over 1 minus r. So let's go and substitute whatever we know. So S of n, for this particular case, T1 is 1/2, okay? And you got 1 minus r is 1/2, okay? So again, you have to multiply 1/2 to get to the next one, multiply by 1/2. Okay, so again, you can see that r equal to 1/2, okay? So times by 1/2, you get that. Okay, so it'd be 1/2 to the n. And if you simplify a little bit, okay, right, 1 minus 1/2 is 1/2. And notice you got 1/2 up here, so this will cancel out. So Sn for infinite series will be equal to 1 minus 1/2 to the n. Okay. Now, if you notice for this one, it gets smaller and smaller. So if you go to infinity, if you go to infinite times, this will approach to 0. So S of infinity is going to be approximately equal to, so S of n will approximately equal to 1 minus, again, when this becomes really large, this is going to be about to equal to 0, okay? And so S of n will approximately equal to 1, okay? Now, not all the infinite geometric series have sum, okay? So if you look at on the bottom of page 531, so you got 1 plus 10 plus 100 plus 1000 plus dot 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 dot. This one will have no sum, okay? So this one have no sum. So what happens is in order to have a sum for infinite geometric series, okay, so for infinite geometric series, you need to have an absolute value r is equal to less than 1, okay, in order to have a sum. Okay. Now, another easy way to tell is, instead of memorize, easy way to tell is look at the number. Don't worry about the sign, just ignore the plus minus sign, just look at the number itself. If the number is getting bigger, then will be no sum, okay? So again, in order to have a sum, the number has to get smaller and smaller, okay? So let me give you an example. So if you just look at some of this example right over here, so you can notice the number is getting smaller, so there would be a sum. Okay? Notice the number is getting smaller. Again, don't worry about the positive, negative. Just look at the number itself. When the number is getting smaller, then you will have a sum for infinite geometric series. But notice over here, this number is getting bigger, so there will be no sum. Okay? So same thing over here. Right? The number is getting smaller, so you will have a sum. This over here, the number is getting bigger, right? So there will be no sum. Okay? And this one is not as obvious, but if you just flip it over, you can see the number is getting smaller, so this will have sum. Okay? So that's what this is talking about, that in order to have sum, that's what this means. Okay? So again, when ratio is less than 1, the absolute value of r equals less than 1, the number will get smaller. So again, in order for infinite series to have sum, okay, you need to have the number has to get smaller. So this one have no sum because the number is getting bigger. Okay. And so the formula, again, let's go back to the original formula. S of n, right, equal to T1 times 1 minus r to the n over 1 minus r. Okay? So what happened is, for the infinite geometric series, okay, when n becomes infinity, okay, so what happened is, when n becomes infinity, this becomes 0. Okay? And so you just end up, when you distribute, you will just have T1 times 1 will give you T1 and will be 1 minus R. Okay? So that's where this formula came from. Okay? See this formula? This came from here, and because in the infinite geometric series with R, absolute value of R less than 1, when this becomes infinity, this will equal to 0. Okay? And so this equation becomes this. So this came from here, okay, with this part equal to 0. Okay? Okay, so now once we have the formula, now we can go ahead and do some examples. Okay. Okay, let's go to example 1, A. And you have 8 minus 4 plus 2 minus 1 plus dot, 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 dot. So this is infinite series. Okay. So again, the number is getting smaller, so there will be a sum. So write down your infinite series sum equation. So S equal to T1 over 1 minus R. So it's very easy. So S will equal to T1 is 8, 1 minus. Now the ratio, you have to be careful, right? To find a ratio, you just put one term over the other. So negative 4, so R equal to negative 4 over 8 equal to negative 1/2. Or you can just put this one over this. It doesn't matter. Pick any term and put over the previous term. So if you do this one, it'd be negative 1 over 2, right? Okay, so make sure you put in parentheses like this, okay? Okay, that will help you to keep track of your signs. Okay, so S will equal to 8 over 3 over 2. Okay, so this is a complex fraction. Okay, so to simplify complex fraction, what you do is the easy way to do it, just go and multiply by the common denominator. So this is 8 over 1. Okay, so common denominator is 2. So multiply the top by 2, bottom by 2, so that these 2 will cancel out. So S will equal to 16 over 3. Right, 2 times 8 is 16 and over 3, and that's your answer. Okay, then now let's go look at the B. This is example 1A and example 1B. You got 8 plus 12 plus 18 plus 27 plus dot, 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 dot. So again, remember, the number is getting bigger, so there will be no sum. Okay? Now again, this is only for geometric, okay? For geometric infinite sum, infinite series. Okay. Now let's go to example 2. You also can use infinite series to convert repeating decimal into fraction. Okay, so for example, example 2, you got 0, 1, 2, 1, 2, 1, 2, dot, 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 right? Okay, so what you want to do is, so this goes on forever, so what you can do is change this into infinite series. Okay, so make this equal to 0.12, okay, So that's that, plus 0.0012 plus 0.000012. Okay, plus dot 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 dot. Okay, so now this become infinite series with r equal to 0.01. Okay, you can just put this over this, and that's how you figure out r. Okay, and notice that this is shift over two times. Okay, so you can you can figure it out. Okay, so r, you just pick any term, put over the previous term. Okay, and that's how you get that. So now you can figure out, so you got s equal to, again, write down your formula, and then you substitute, so s equal to t1 is 0.12 over 1 minus 0.01. So s equal to 0.12 over 0.99. Okay, move decimal 2 places over, so s equal to 12 over 99. And you can reduce, okay, divide by 3. And so s equal to 4 over 33. Okay? And you can check your answer, see if it's correct. All you have to just go use 4 divided by 33, push equal, see? So that's 0.1212121221. Okay? Okay?